Question 9 in 2022, Alex gets injections of a medicinal drug and each injection has 15 milligrams of the drug. Each day, the amount of drug left decreases by 40%, so there's going to be 60% of the original left. 60% left, which you can see is in here. And the 15 is before it, and the formula is given here, so that t days after t days, we'll call this y is equal to. So find the amount of drug left 2.5 days after a single injection. So t is equal to 2.5. Just sub it in here. Y is equal to 15 times 0.6 to the power of 2.5. That's giving me 4.1828. Correct 2 decimal places. 4.18 milligrams. I'll put the units in. Will be left if he just gets one injection. How long after another single injection will there be 1 milligram left? So just write your formula, 15. So when will this be equal to 1? How long? We're looking for t. So you know this is going to be log rules. Do it in a couple of simple steps. Divide by 15. And then get the log of both sides by bringing t by the log of 0.6. Will be the log of 1 over 15. I'll leave it as a fraction. So t will be equal to these two negatives divided by each other. The log of 1 over 15 divided by the log of 0.6. You've done hundreds of these. T is equal to 5.3, and I'm going to sub that back into the equation. 15 by 0.6 to the power of 5.3. On my calculator, it's giving me 1.0000, and then a 6 actually is the third or fourth number. So you can see that we're correct here. So always sub back in if you can. Give yourself a bit of confidence before you move on to part C in this question. Part C, Alex is given a 15 milligram injection of the drug at the same time every day for a long period of time. Explain why the total amount of drug in milligrams in Alex's body after the fourth injection is given by this. Well, we had our equation, y is equal to 15 by 0.6 to the power of t. I think what they're looking for here for this explain is just this time equals 0 is the initial amount. So we're to imagine that this guy, when time is equal to 0, you'd imagine before he even gets the drug, there's going to be 15 milligrams. So that's my first term. And then subsequently, second, I think well, it's probably enough so far, is 15 by 0.6. And the third would be 15 by 0.6 squared and so on. I think that's enough of an explanation. Find the total amount of drug in Alex's body immediately after the 10th. So this is sum of n terms, which you all know without looking up the tables, is a times 1 minus r to the power of n over 1 minus r. We have our a here, our initial amount, 15. My ratio, looking above, we're just multiplying by 0.6 each time. Subbing this into the formula, 15 times 1 minus 0.6 to the power of 10 divided by 1 minus 0.6, or just write 0.4. This is giving me 37.273. Correct to 2 decimal places. 37.27 milligrams after 10 injections. Part D. Use the formula for sum to infinity, this magic word that you should identify straight away. Sum to infinity is just the a over 1 minus r. The ball bouncing geometric series, you were told this was coming up. So a is still 15. Or still 0.6, so we have 1 minus 0.6 on the bottom. And 15 divided by 0.4 is 37.5 milligrams, very close to, you can see here there's only a max amount that he'll end up with in the system. 37.27 was the last one, 37.5 for the last part of Alex's injections. Now on to Jessica's injections. Jessica also gets these daily injections of a medicinal drug at the same time every day. She gets D milligrams, so we don't know what it is yet. And each day the amount of drug left decreases by 15. So kind of junior cert maths, there's going to be 85% left. So there's going to be D initially, same as the last one, 0.85 D. No, and then the third one will be, I should really put the D in front. I shouldn't have to, but 0.85 squared times D, and so on, will be this series. So what are we asked to do? Use the sum of a geometric series, Sn, again in the same question, a times 1 minus r to the power of n over 1 minus r. How many times did you do this in practice? A is equal to D. You may look at this and get confused, particularly if you can't see the bottom part of it, but you shouldn't really get confused. Don't look at this, just do what you know mathematically and see what happens. R is equal to 0.85 for this series for Jessica. So just filling this in, we're going to get D times 1 minus 0.85 to the power of n, which is inside the bracket up here. Good start. Over 1 minus 0.85. And really what you're asked to do here, 0.15 is a decimal. That's equal to 3 over 20. So this is the bottom of the fraction here. So we're going to get D times 1 minus 0.85 to the power of n divided by 3 over 20, just to show you what happens when we divide by a fraction. Well, we turn it upside down and multiply, so it becomes 20 over 3. And that disappears, so you can see we get what we're looking for, 20D. Just converting fractions to decimals and not the other way around. 1 minus 0.85 to the power of n over the 3 gets left on the bottom. And then the last part of Jessica. So immediately after the 7th injection, there are 50 milligrams, so the sum of 7 injections will be equal to 50 for Jessica, and she was A, let's just write it out again, 1 minus r to the power of n over 1 minus r. So S7 is going to be equal to A, the initial amount, which we don't know, this is what we're looking for, which is D, 20D, actually 20D, we'll just actually use the formula, so it's visible, 20D by 1 minus 0.85 to the power of 7, just make this a bit neater, 20D over 1 minus 0.85 over 3 we have from above, I'm confusing the two. So typing this into a calculator, we know S7, I'll give that, we're told it's 50. Should have laid this out a bit better. So 50 will be this guy, just so I can cross multiply in one stage here. So I'm going to multiply the 3 by 50. And then I'm going to divide by 20. So it's 150 over 20, 7.5. So that's 7.5. And then I'd have to, on the right hand side, what will be left is D times 1 minus 0.85 to the power 7. So divide by 1 minus 0.85 to the power 7. That should give us D, the amount of her injection, the amount of the drug in one of her dailies. So this is giving me 11.03 milligrams. Correct to the nearest milligram. Finishing this question, Jessica, 11 milligrams.